The development of atomic theory begins with the ideas of Democritus. Now, Democritus was the one, he was an ancient Greek, lived about the time of Aristotle, and the Greek model, where Democritus come from, we always think of the American flag and democracy, uh, this would be the one saying that an atom is indivisible or undividable. Democritus' idea was that there's, if you took something like a piece of wood and or a piece of cheese, or let's just say a piece of copper, and if you were to take that copper and rip it in half, well, then you could take what you had left and cut it in half again, and then cut that smaller piece in half, and keep cutting it in half until you get down to one piece of copper that would be so small it would be undividable or indivisible, and that's what he called the atom. In fact, the word atom comes from the Greek word atomos, which means undividable or indivisible. Later on, we had the American flag, and then in my class we had the mnemonics where what was carrying the American flag through the doorway was the doll baby from Toy Story, was marching through the doorway, and the doll reminds me of Dalton. Dalton was the next in line when we're talking about atomic theory. He took the ideas of Democritus and expanded upon them. And he said, okay, I agree, there's this thing that is so small that it's undividable, but I'm going to go a little bit further, and I'm going to say that different elements are made of different types of atoms. Copper atoms are made of different atoms than hydrogen atoms are, and aluminum atoms are different than sodium atoms are. He also said that all atoms that are copper are going to be identical to each other. There's, copper atoms are copper atoms. They don't change. And so I always say it's all right to be different. At the end of Toy Story, Woody and Buzz were scared of the doll babies because they were a little bit different, but they were actually nice and they helped them at the end. So, remember, it's all right to be different. So Dalton's idea was different elements are made of different types of atoms, but also in the same concept, similar atoms are going to have similar elements. Copper atoms are always going to be copper. Hydrogen atoms are always going to be hydrogen. So we got Dalton. Thomson was the next model that comes along. He agreed with everything that came before him. He's like, yes, there are these things that are undividable, and different atoms are made of different types, or different elements are made of different types of atoms, and similar atoms are made of different similar atoms. But he said within the atom, he discovered the electron field, the negative charges. And we had Tom, the cat, was chasing the doll baby through the doorway. And then we had, he ran into the electrical outlet, and he was covered in plum pudding, dripping all over Tom. He was sliding all around, ran into the electrical box. And of course, the electricity is the flow of electrons. And so we have the discovery of the electron. But Tom essentially said that the electrons were scattered throughout the atom equally, almost like plum pudding like we see over here. There was no arrangement to those electrons that were within those. So then we had the next one that comes up. We have Rutherford, and we have the rubber fork, stabbing Tom in the rear end. Rutherford agreed with everything that came before him. Yes, there's indivisible. Similar atoms are made of make up similar elements, and different ones make different elements. There are these things called electrons, but there was something new here beside the electron. And he did what was called the gold foil experiment, where he shot these positively charged particles through gold foil, and some of them passed through, like shooting a bow and arrow through a haystack, but some of them bounced backwards. And he knew that since like charges repel each other, the only thing that can make that positive charge when I shot it at the gold foil to bounce back will be something else positive inside there. And so he formulated the idea of the positively charged nucleus. There's protons in the nucleus and also neutrons we later discover, but the positively charged in the nucleus, the protons, are what bounce those positive charges backwards. And so we have Democritus was the first one, or the Greek model. The atom can't be split. We have the Dalton's, which says different elements are made of different types of atoms, or similar elements have similar type of atoms. We have Thomson, covered in plum pudding, dripping, running into the electrical box, discovered the electrons, but he said they were like plum pudding. They were all mixed up in there. And then we have Rutherford, or Rutherford, who gives us the opposite, where Thomson discovered the electrons. Rutherford discovered there's something charged in the nucleus there, positively charged, that was bouncing it backwards, because like things repel. So he discovered a positively charged nucleus. Then we get Bohr. We got a board here. And the thing to remember with Bohr, those are the models we typically use. They have shells nailed to them. So I took some seashells and nailed them to the board here. The Bohr model is the one we've been using in class all the time. Bohr took everything that was before him and said, yes, there are these electrons. They're negatively charged, and there's a positively charged nucleus. However, those electrons are not like plum pudding, all randomly scattered throughout the atom. They're in these shells that go around in orbits around the nucleus. And we know they can have up to 2 in the first shell, up to 8 in the second shell, up to 8 in the third shell. So he rearranged those electrons and how they were arranged around the nucleus. So we're developing a more complex atomic model now. And then finally, we get to the end. We see who is stabbing the fork into Tom over here. He's got the board with the shells nailed to it. Well, who is stabbing that is our quantum, our Con-Tom, the quantum model, also known as the Schrodinger model, or the slow danger. He was poking Tom in the rear and telling him, slow down, quit chasing the doll baby through the hallways, especially if you're covered in plum pudding. The Schrodinger model, or the quantum model, the Con-Tom model, is also called the wave model, or the electron cloud model. We see Tom waving up here. He's waving at the other Tom, telling him to slow down. The quantum model, or the wave model, or the electron cloud model is this model. And it differs from the Bohr model in that the electrons don't orbit around like the planets orbit around the sun. They're within a fixed area of probability where they can show up, but they're not locked into these fixed orbits, and they're traveling at near the speed of light, and they form a three-dimensional cloud. Now this is showing a hydrogen atom right here. We know that hydrogen has 1 proton and 1 electron, but that 1 electron is moving so fast in random orbits all around it, forming a cloud of probabilities where that electron can occur. This is the cloud model, and it's like a fan's the blades on a fan, that you might have like 3 blades on a fan, but they're spinning so fast that they essentially act like one thing. You can't stick your finger through the fan blade because it acts like a solid object because they're spinning so fast. It's almost, you can think of it the same way with here, with that 1 electron spinning so fast at near the speed of light and going in random orbits all around this thing. It's just spinning all around it randomly. It's staying within that 1 area of probability, which is similar to the first orbital here of the Bohr model, but it's just random. It's not locked in, just traveling around that 1 path.